So today we are going to learn how do we integrate a logarithm function. So we learned in calculus AB 1 over x, when we take the antiderivative, give us ln absolute value of x plus a constant c. 1 over u du also give us ln u. So this tells us sometimes we can use u substitution, define a new function, and substitute the original equation. So 1 over u times u prime dx. This part is exactly du, because du equals u prime dx. So let's have a look at some examples. So example 1, integration 2 over x dx. We can move 2 out directly. So this gives us 2 ln x plus c. So now if you look at the second example, the coefficient of x is now 1. So you can use u substitution. So the only difference right now is ln for x plus 1 plus a constant c. So if you define u equals 4x minus 1, so du will be 4 dx. Right, so now the problem becomes integration 1 over u times 1 over 4 dx. This is 1 over 4, 1 over u du. This is exactly where this 1 over 4 from. And the practice problem, I'm going to go over some of the problems, and sometimes we do have to use u substitution. For example, example 1. So we are going to define u is x cubed minus 5. So du will be 3x squared dx. Now the problem will be replaced. All the x and dx will be replaced by u and du. So it's du over u. Give us ln u plus c. Now we plug u back in. Minus 5 plus c. This is our final answer. Let's look at example 4. So in this case, as we know, the derivative of tangent gives us secant squared. So we are going to define u is tangent of x. So du will be secant squared dx. So we replace everything using u and du. So du over u. It's ln u plus c. So this equals ln tangent of x plus c. Now you can pause the video for 2 minutes and finish example 2, 3, 4, and 6. You can compare your answers with mine, and if you have any questions, please let me know. Now let's have a look at the integration of some basic trig functions. So integration of sine gives us negative cosine. Integration of cosine gives us sine. We are very familiar with these two. However, integration of tangent gives us negative ln cosine of u, and integration of cotangent gives us ln sine of u. And then everybody look at these 6 formulas carefully. Then we are going to practice the problems using these formulas. So integration tangent of 5x will give us, if you look at the formula here, u equals 5x. So du equals 5 dx. So integration tangent u 1 over 5 du give us 1 over 5. So u now equals 5x. So it's negative 1 over 5 times ln cosine of 5x plus c. So similarly, this will be secant u will be 1 over 9 ln secant 9x plus tangent 9x plus c. Cosecant 8x and cotangent 13 of x. Everybody can try it yourself. So if you finished, you can compare your answer with mine. So some students might have some question, how do we get this? Integration tangent of u du or tangent of x dx, how do we solve it? As we know, tangent of x equals sine of x over cosine of x dx. Let's define u equals cosine of x. So du equals negative sine of x. Integration negative du over u. That's why it's negative ln u, which is ln cosine of x plus c. This is using u substitution. We can derive these formulas ourselves. Let's look at more examples. If we look at example 2, this is definite integral. So this definite integral, as we know, 1 plus tangent squared give us secant squared. Because secant is always positive from 0 to power 4, so we can get rid of this square root directly. And based on the formula, this gives us ln secant x plus tangent of x from 0 to power 4. And the secant of x equals 1 over cosine. So now we plug 0 and power 4 in, give us ln square root of 2 plus 1 minus ln 1, which is 0. So our final answer will be ln square root of 2 plus 1. Example 3. How do we find the average value of fx equals tangent of x in the interval from 0 to power 4? So the average value, 1 over b minus a, integration from 0 to power 4, tangent of x. So this gives us 4 over pi, integration 0 to power 4, tangent of x dx. Based on the formula, tangent of x antiderivative is negative ln cosine of x from 0 to power 4. We plug everything in, give us it's negative here, ln cosine power 4 minus ln 1, which is 0. So our final answer, negative 4 over pi ln square root of 2 over 2.